Okay, now let's look at this question 2. This has to do with Newton, second law. So we have a crate of crate P of mass 1.25 kg, and it's connected to another crate Q that has the mass of 2 kg. So the two crates are placed on a rough horizontal surface. A constant force of magnitude 7.5 acting at an angle theta to the horizontal is applied on crate Q. As shown in the diagram, the crate accelerate 0.1 meters per second squared, and this is going to the right. So crate P experiences a constant frictional force of 1.8. So I'm going to indicate that on my drawing. Okay, so the crate P frictional force will go in an opposite direction. So this is my frictional force, and they say the frictional force is 1.8 newtons. Then crate Q experiences a constant frictional force. So this crate will have a frictional force that is equals to 2.2 newtons. State Newton's second law. Okay, so to state this one, I'm going to state the Newton's second law using the formula that says F net is equals to ma. This is the Newton's law formula. It says that when a resultant or a net force acts on an object, okay, so it says when resultant or a net force, when a resultant or a net force. If it acts on an object, we say the object will accelerate so it will accelerate in what? In the direction of, it will accelerate in the direction of the force. So, but now the acceleration is going to be directly proportional. Guys, I'm going to finish this definition by writing it in symbol. The acceleration is directly proportional to what? To the net force. So acceleration is directly proportional to F net, and we are saying that it's inversely proportional to the mass. So the acceleration, it's inversely proportional to the mass. Right. So directly proportional means that if the net force increase, the acceleration also increase. Inversely proportional means that if the acceleration increase, the mass decreases. You see something like that. Okay. But you can also use your exam guideline, guys. I don't like to stress on definitions. You can just define it using your exam guideline. Okay, so now 2.2, they want you to draw a label free body diagram for crate P. So I'm going to indicate all the forces that are acting on crate P. We have a tension going in that direction. We have a normal force acting up, and then we have the FG perpendicular going down. And then look at this. The mark allocation tells you that this is 4. You need to indicate, to answer this 2.2, you need to indicate how many forces? 4 forces. So this is your Fn, and this is your Fg. Then there's a force that goes in that side, which is the tensional force. And the last one in an opposite direction, that's your frictional force. And you'll definitely get the 4 marks. Okay, 2.3, calculate the magnitude of the tension in the string. And to calculate the magnitude of the tension in the string, I'm going to use Newton's second law, right? First thing first, write down the 2.3.1. Say F net is equals to MA. Okay, then when you have the F net is equals to MA, you need to, they say, the tension in the string. They want us to calculate the tension in the string. So look at this. If I have the frictional force, okay, so it's going to be easy if we use the crate P, because crate P has only 2 forces. I can't use crate Q. Crate Q will make everything to be more complicated because we have the horizontal force we have the frictional force, the tension and the frictional force. So for this crate Q, if I draw a free body diagram, this will be my Fx, this will be my tension, and also my frictional force. So I know that I have two unknown, which is Fx. I can't find Xx because I don't know what is angle theta. I can't find Fx, and then I can't also find I can't find tension because I have two unknown. Tension and the Fx, the horizontal component, unknown. So I'm not going to use crate Q, but crate P, it will be easy for me to draw a free body diagram on that, indicate the horizontal forces. This is my tension. Then I have a force going that side, which is my frictional force. So it's easy to use crate P because only two forces are acting on that crate P. So when I say F net is equal to MA, I'm going to choose direction. Direction of the motion as positive. So right as positive. Then I take all the forces that are going to the right. I subtract all the forces are going to the left. Equate this to MA. Okay, so now I'm just going to do my substitution. They set the tension for that crate P, it's 1.8. So this will be, we take the tension, we minus the friction, which is 1.8. 1.8, this is equal to the mass we are using, crate P, which is 1.25. The acceleration was given, I still remember on the statement, it was 0.1 meters per second. So I'm going to say this is multiplied by 0.1 meters per second. Then now what will be the tensional force? We're going to say this is 1.25 into 0.1. Then take the 1.8 to the other side, it becomes positive 1.8. The answer that you get, that will be your tensional force. I'm just going to try and put that on the calculator. So this will be 1.25, 1.25, close the bracket, 0.1, close the bracket, then we add 1.8. This gives us the tensional force of 1.93 if we round it off to 2 decimal places. That's your tension. Easy formats, ne? Right, tensional force 1.93 newtons. Right. Then the last question of this one, it says they want you to find the angle theta. Okay, so the angle theta. So to answer this question, the angle theta is the angle between the horizontal component and the applied force. And we know that we use this when we do the Fx. So what is the Fx? Horizontal component. Then it's a horizontal force. You're going to draw a free body diagram for that horizontal, for all the horizontal forces that are acting on that plate Q. So when I indicate them, I'm going to have the Fx to the right, the tensional force to the left, then the frictional force to that side. So if I say F net, it's equal to MA. I'm going to say I write as positive again, write as positive. Then now I know that I need to take my Fx minus the tensional force minus the friction, equate this to MA. But if you still remember, if I have the applied force like that, and then I'm going to have the force going up, which is my Fy. So I'm going to say I am looking for Fx, which is my eigency, and I have F, which my hypotenuse. So according to SOHCAHTOA, I have eigency and hypotenuse. This will be the cos of theta. So now this tells you that the cos of theta is equal to eigency, which is your Fx, over hypotenuse, which is F. Therefore, multiply both sides by F. What is your Fx equals to? So the formula for Fx is F, the cos of theta. So I think everyone already knows that. So where there's Fx, I can substitute F, the cos of theta. We minus tension. Do we know what is tension? Okay, it's fine. Let me just do the substitution first. Let me just rewrite everything, then I'll do the substitution now. So F cos theta, do we know the applied force? The applied force is given as 7.5. So I'm going to put in this as 7.5. And then the cos of theta, then I'm going to minus the tension, which is what we just calculated. The tension as 1.93. So I'm going to minus 1.93 minus the frictional force of crate Q, and we said is 2.2. So I'm going to minus that 2.2. Then I'm going to equate this to the mass of crate P, crate Q, which is 2 kg, times the acceleration of 0.9. 2 into 0.1, not 9, 0.1. Therefore, this will be like, okay, let me say 7.5, the cos theta, and see what is this equals to. So this will be the cos of theta. This will be equals to, I take these two guys to the other side. So basically, this will be 2 into 0.1. Then we're going to add 1.93. We add 2.2 and see what is that equals to. Okay, we're going to take 2 into 0.1, and then we add 1.93, then you add 2.2. Then this gives us 4.33, right? So this tells us that this will be 4.33. Then now you can divide by that 7.5 on both sides. Divide by 7.5 on both sides. What is the cos of theta equals to? So the cos of theta is equals to, we're going to say answer divide by 7.5. This gives us an answer of 0.577. So it's 0.577 and so on. Therefore, theta will be the cos inverse of that 0.577. What is theta equal to? The cos inverse of answer, because I don't want to round off. The theta is 54.74 rounded off to 2 decimal place. Theta is 54.74 degrees. That's the angle theta. And that's it for this question. This is how you collect that 13 marks. Easy, right? So I'm very sorry about the Newton's law definition that we did not manage to finish the definition, but it goes like this. When a resultant or a net force acts on an object, the object will accelerate in the direction of the force. The acceleration is inversely proportional to the net force, and is directly proportional to the net force and inversely proportional to the mass. That's the definition. And I want us to work on the next one, the next question. Okay.